Yeah, it's a good piece of song or music, whatever you want to call it. But I guess we have to start the stream anyway, so good evening everyone, and welcome to 107th livestream, hacking livestream, or whatever you want to call it. Today we are going to be doing something weird. We are going to try to compile Qbasic, which, and I'm not really sure even how to approach it yet, so, but do expect custom stuff. Basically, I'm just like not going to grab a compiler of a shelf, type make and be done with it. It's probably going to take a little bit more time. Now, today's moderator, wait, misclick. Today's moderator is KrzaQ. KrzaQ's nickname is here, but since we have a YouTube bot, you don't really need it. I think you can just type !Q and then the question. And the question will appear in our question panel so I can answer it. If you're on our Discord or if you are on our IRC chat, that also works. You can type !Q and the question, and it will get to my question panel so I can try to answer the question. Now, today's live stream is going to be exactly 2 hours, so until 10 p.m. my time zone. Why? Because when SpaceX launches some, Demo 2, the crewed mission to the space station, and I know a lot of people want to watch it, so let's just not overrun the time today. Perfect. Cool. Now let's do some random stuff, and as usual, like around 10 past, maybe 15 past, we'll get to the main topic, and we can chat there and then. This is KrzaQ's website. KrzaQ is, as you know, my moderator today, and yeah, just visited, and actually there's a new blog post. KrzaQ actually told me that he published it just before the last live stream, so I was supposed to show it on the live stream, but I actually preloaded his website like 15 minutes before the live stream, so, or like even 20 minutes. So yeah, like that didn't work. Well, here it is today. Adventures in returning value-dependent type, a new post from KrzaQ. Absolutely check it out. I am going to paste you links right now to his blog. Now, before we get here, this is, if you're into security, basically there's another online conference tomorrow. Actually, not a conference, it's a small event with, I believe, 4 speakers. 4 speakers. I think one of the talks is in Polish, but the rest it will be in English. So yeah, if you're interested in these talks, it's just check it out. It's a conference where I'm one of the people behind the program, so I know the speakers are cool and I know they are good, so you can check it out. I think the ticket costs like 70 zlotys, which is how much is it? PLN, and let's convert it to euros. That would be 15 euros, or USD, that's 17 USD, so yeah, that's not super expensive. At least I think so. Especially for this caliber of speaker, so you can take a look. Otherwise, if you're interested into actually going to the real conference, I think it's going to be in September. 2 days, 3 tracks of quite a lot of amazing speakers in Poland as usual. Perfect. Now, this is the topic of today's live stream, is Qbasic. I'm going to give you the link as well, so you can take a look. And yeah, the last commit was 38 years ago, like even before Git existed, I guess. And yeah, and this is what we'll be playing with today. I did give you links on both chats, so you can take a look, but we will get there in a second. I guess I'm going to, I don't know, I'm checking if there are any questions, but I don't think there are any questions, so maybe we can actually begin the live stream topic a little bit earlier than usual. So yeah, let me do a historical introduction. What is Qbasic? Okay, I know some of you heard of it, some of you actually programmed with it. I did, that was like Qbasic was the 3rd or 4th, I think the 3rd basic variant which I programmed in. And that wasn't in 83, obviously. It was a little, like, several years later. But what's the story behind it? So the story is basically that if you think about 8-bit computers, like for example, let's say Atari 800 XL or Commodore like C64, then if you, let's go to images. What I'm looking for is basic. Okay, so yeah, basically when you launch, we don't want the YouTube video. Basically, when you run the computer, as you can see here, you just power it on and then suddenly you are in a basic editor. Like, you do not have an operating system per se, unless you had a floppy disk drive, but otherwise you wouldn't have it. You just power on the computer and bam, you're in a programming language editor and you can start playing with it and you can write programs, run commands, and so on. So this is like, think about this in comparison to today, right? Today you don't really have that, and it was the same by the way with Commodore 64. You also would be booted into the basic. And by the way, for actually let me show you Commodore 64 basic for 1 second. Basic, because there's a so this looks like this. Now, Commodore 64 basic was written by Microsoft. So yeah, the same Microsoft which does Windows. Microsoft was in the business from the beginning of writing basic interpreters. Basic is a really old language. It's a language from, I think, 1965. And yeah, but when Microsoft basically created their business, they implemented basic interpreters for various platforms. And Commodore was one of them. I think they also written one for Atari 800 XL, which I shown here, but in the end it was too big and it didn't fit the ROM, so Atari basically had to implement their own basic version. Anyway, what I'm going after is basically that, yeah, you turn on the computer and you get a basic interpreter. And this isn't true for current modern computers, right? You can boot the computer without any hard drives, and what happens? Well, you can go to BIOS. And is there a basic interpreter in the BIOS? No. Well, there is no BIOS, there is UFI, UFI, or whatever you want to call it. But there is no basic interpreter. Was there a basic interpreter in like PC computers? Yes, actually there was. When basically the first company creating PCs was IBM, and when IBM started creating computers, they had a basic interpreter on the BIOS, and there was an interrupt. I think it was interrupt 18. And yeah, basically if you would call interrupt 18, your computer would reboot and it would jump into the basic interpreter on a PC, on an IBM PC. And actually, clones did not have an interpreter. It was only on original IBM PCs. Now, yeah, like if the computer would boot without finding any operating system on any hard drive, or rather on any floppy disks, it would also jump into a basic interpreter. Now, what basic interpreter was that? Well, that was GW Basic. So this is where we get. It wasn't code like that when it was in the BIOS, but at some point Microsoft took the code from the BIOS and ported it as a standalone executable for Microsoft DOS. So when you installed Microsoft DOS, you would get GW Basic. I think that was the case. I might be wrong here if it actually came with Microsoft DOS. That's because from Microsoft DOS 5, I think it was from the Microsoft DOS 5, Microsoft actually created a new interpreter for BASIC, which was more modern, and it was called Qbasic. So now Qbasic, I can actually show you a screenshot. I should show you screenshots for GW Basic. It looks like this. Here we go. This is from ASA. Okay, but this isn't a good quality I was looking for. This looks way better from... can I zoom it? Any good quality images on the internet? Yeah, this looks perfect. Yeah, this is exactly how it looked like. So it was, as you can see, pretty simple. Like basically this was like, let's say, an interpreter part. The weird stuff in languages back in the days was that each line you'd have to write the number manually. As in, you would say line number 10 and then the command, line number 20 and then the command. Why isn't it line 1, line 2, 1, 3? Because if you would make a mistake, you like forgot a line of code or 2 lines of code, then you could write line 11 something and line 12 something, or rather that would be actually more like line, let's say, 14 and line 17, so you still have some space in between them. And yeah, and this was basically like any line number followed by a command would put that line in a linked list, usually of basic commands to be executed. And if you had a command like list, it would print you all the lines with all the actual basic commands which were there. Input A, this doesn't really differ from in Python from like A equals to input. So yeah, print is also there, like print. This print C could easily be Python code anyway. You can see that everything is capital letters. And yeah, it's a pretty high level language at the end of the day. And yeah, and then you typed run and it would execute. You also had some, these are like for function keys. If you press like F1, it would actually list the code. If you would press F2, it would run the code. There is no compilation, there is nothing else like that. So yeah, that's basically Qbasic, which we will be compiling today, or rather through the next couple of live streams. Now I mentioned Qbasic. This is the Qbasic. I mentioned Qbasic, so let me show you the next thing, which actually it looked like. I guess we can go for the screenshot. It's an Israeli thing, but I'm only interested in the screenshot. Here we go. Yeah, this is how basically Qbasic looked like. It's still in the text mode, but has a little more modern feel. You did not have to do any line numbering anymore. You could, it was optional, but you didn't have to. And you could do subroutines instead of just jumping to a certain line number. And it was, had more of a feel of it looks closer to a modern editor than the interpreters used like before, like Qbasic. Cool, so that was a historical note on Qbasic, what is Qbasic. And Microsoft released the source code for Qbasic from '83. The original source code for Microsoft Qbasic interpreter. And there's a blog post and there's some information, and basically there's a license which is MIT, which is perfect. That's a really, really nice license. And yeah, at the end of the day, how do you compile something which was written in '83? I have no idea. And that's basically the topic of today's stream. How are we going to compile it? I think it's for the actual platform this was built for was, and we are going to confirm it, but I think that was 8088, which is pretty close to 8086, as in like assembly, right? And if so, we can probably compile it to something like 16-bit assembly, and maybe we can get it to run under DOSBox. So that's one of the ideas. We are going to double check these assumptions later on. Another idea is to not do that, to compile it to a modern platform. What are the issues here? Well, actually this is supposed to be running probably under DOS, right? Under Microsoft DOS. Now, DOS actually supplied its own API, and the API was available on the interrupt 21H. There was like a whole list of functions, so you basically put in the AX register the number of a function, or that could be like AH or whatever, AL, depending on some stuff. And you put the number of the functions, you put stuff like parameters in different registers, and then you called this interrupt, and it would jump into DOS, and DOS would run a given function for you. So that was one API which this probably uses. The second API that this probably uses is like actually quite a lot of APIs that would be and whatever, because that's the BIOS API and video BIOS API. So the APIs of whatever BIOS is giving you and whatever is given to you by the video graphic cards BIOS as well, because when you start a computer, I'm not sure if that's still the case, but back in the days it was the case, but when you started the computer, your BIOS would start going through the devices attached to your, for example, PCI or like ISA buses, and would ask them, hey, do you have any x86 code that you would like to run? And if the device said, yeah, totally, then that firmware would be run on the main CPU, and what that firmware usually did is it supplied a new API to be used later. And this is also what this code is probably using. It's probably using a lot of BIOS API, maybe some video card API, and that might be different types of video graphic hardware. Back in the days, there was different graphic hardware as well. Now we are used to like AMD and, you know, like NVIDIA and Intel. And from a programmer's point of view, it doesn't really matter too much. Like the cards have their own extensions to like Vulkan or OpenGL or whatever to DirectX, but at the end of the day, yeah, if you don't care about the extensions, you just basically code whatever and it runs anywhere. If that wasn't the case back in the days, there were a couple of different standards of graphic cards. For example, like I had something which was called Hercule, which was a black and white, high resolution graphic cards. Then there was, for example, CGA, which was a color graphic adapter, which could run anything between 4 to 16 colors, depending on how hacky your code would be. And then, like, more happy people had EGA, which could run 16 colors, and VGA, which is the modern standard, or rather what the modern standard is following. It was 256 colors, and then Super VGA, which was like, and that's, yeah, Super VGA is basically what spanned the modern graphic cards, and on top of that, at some point, people started adding all the 3D stuff. So yeah, given the times this code was written in, I kinda think it might support like these 3 types of graphic cards, so yeah, that might be quite funny. Yeah. Now, yeah, so if we would like this code to run natively or semi-natively on a modern platform, we would have to find the parts, basically, of the code which interacted with the old API and then replace them to interact with the new API, like of Windows, of Linux, and basically translate that API. And also the problem is, like, let's take a look at one of these files, I don't know, like at random, GIODSK, whatever that means. Let's see what we have here, like, really quickly. Yeah, this absolutely looks like 16-bit assembly, 16-bit x86 assembly, so that's good. Yeah, that's absolutely 16-bit assembly, and the good news is that it's x86. The bad news is that a 64-bit operating system has absolutely no way to run this apart from emulation. What we could do is we can either use an emulator like DOSBox, which also supplies the BIOS DOS APIs, or we could translate this code into Python. For example, like we take each line and translate it into Python. Is it going to be slow? Yes. Is it going to be slower than this code running in 83? Absolutely not. Like modern computers, even Python is fast enough to emulate this code. And yeah, we could do that, and then we could hack into the code a little bit easier and debug it a little bit easier than trying to debug code which is, what, like 37 years old. So that's another idea, to basically cross-compile it, or rather, I know some people like the term transpile it. I actually also like it, yeah. So, or transpile it into another language, another assembly, and try to... This is a hack, like this is a macro, call.os, there is no instruction call.os. So, okay, what's call.os? I guess we will have to kind of take a look with some grep. Okay, so what's the plan? I guess the plan is going to be look around the files, get to know, like do a recon phase, a reconnaissance phase, basically, and get to know what we are dealing with. Can we compile it with something which I have? Probably no, probably the syntax will be different. Can we do some simple regex, like regular expressions, to just convert the syntax? Maybe. Another issue is linking, because as you can see, there are quite a lot of quite a lot of files. So this means it has to be linked. And I guarantee you that even if you would find a compiler which understands this assembly syntax, I highly doubt we would find a linker which would create a modern linker which would create an executable out of that. So yeah, this is like the second problem we're dealing with. We have to somehow link it, and this is regardless if we are going for like translating this code into Python or we are going some other way. At the end of the day, that's what we will have to be dealing with, basically. Cool. Okay. If you have any questions, again, just type !Q and type the question in. I'm taking a look if there are any. Okay, so there's a question. Wait, does CGA have more colors than black, white, cyan, and pink? That's the question from Sovo. Yes, surprisingly. It's like this. You had two different color modes. So it could be the colors which you said. It could be also like, I think, a nasty looking yellow and nasty looking green. And like two other colors. Or I think in text mode, you could have 16 colors displayed. And there was a hack to kinda change the the text mode into semi-graphical mode. And I think on Wikipedia there's actually a nice article about it. Let me quickly find the hack. And I think that's not only it. Yeah, this. This is basically the hack which is using the text mode, but the text mode was limited due to some settings in the graphic cards. You could limit the text mode to 2 rows of pixels. Instead of all pixels, you had like 2 rows of pixels, and therefore you could do graphics. It was a hack, what can I say? But at the end of the day, you get more than the color you mentioned. And I'm pretty sure I saw someone displaying even more colors. Additionally, CGA could be connected to, these are the colors, and you had to basically choose the low or high intensity palette. You could also connect it to, what was it? Like some kind of analog output, which was lossy. What is it called? I have it on the end of my tongue, but I don't remember. Anyway, yeah, you could connect it to like basically like TV, like, oh yeah, here we are. What is it? Composite? Yeah, composite. This is what I was looking for. This composite thing on the right. And due to some quirks, some hacks in the timing module, you can actually even get more colors. But that was absolutely hacking. So yeah, so there we go. Cool. Yeah, CGA wasn't the greatest looking at the time. Like the colors were a bit annoying, but yeah. Yeah, I see on the chat, Karamania is writing that using the composite hacks, you could basically get 1024 different colors on the screen. I think this is either ancient NASM or MASM. I think it was actually called ASM86. Or MASM86, and it had nothing to do with the Microsoft assembler, with the modern Microsoft assembler at least. So, yeah. I actually, a couple of days when this came out, we chatted on the chat about it a bit, and I was looking for like different assemblers which could understand the syntax, but there is a problem with, for example, let's find a problematic line. Here, we have move byte pointer something. NASM complained about having this pointer here. NASM does not put the pointer there. But we can easily fix it. This short here might be a bit more problematic. I'm also wondering what is the syntax with the 2 question marks. It's probably some kind of a local label. But if it's a local label, why do they iterate over it? Then we have this short here. This short actually is quite funny because this is a conditional jump. And conditional jumps on x86 have only the short form. There is no long form for the conditional jumps. The long form is only for this kind of jumps, like non-conditional jumps. So this is also weird. Now, one other thing which is going to probably be a little bit annoying for us is segments. Yeah, so the memory model on 16 bits x86 is probably the weirdest thing you can imagine. Why is it weird? Because, well, we have segments, right? And a segment of memory is, let me like draw it like this. Let's assume this is your conventional memory, your RAM. And a segment would be 64 kilobytes. So starting here, for example, let's say this is segment number 123, because why not? And it's like 64, well, okay, but like the RAM, there's a lot of more RAM here, obviously. And let's say this is like 64 kilobytes. And you would say, yeah, that's quite easy, because then like this would be another segment of 64 kilobytes. So the question is, where is segment 124? Does it start here? No, it starts here, after exactly 16 bytes. And where does it end? Where it ends here. So yeah, like the 125 would start here and end here. And as you can see, the segments are overlapping. So the memory model here is actually really weird. On top of it, there's also the so-called A20, which we hopefully will not have to deal with. If you think about this model, the segment identifier is 16-bit, and the address is like 16-bit, obviously, right? So let me open a notepad for you. What does that give us? Well, that means that if the segment identifier was 16-bit and then you had 16-bit for the offset, it's denoted with a semicolon, by the way. Then you write like FFF, and that's, let's say, like the last address which you can write in. Now, usually there was, I think, only 1 megabyte of memory. Now, 1 megabyte is 0x1 and 5 here. Am I right? Or 6? 6 in total. 6 in total. Okay, yeah, that's fine. So yeah, this is 1 megabyte of memory. Now, if you calculate this using the formula which I said, you take the number of the segment, you multiply it by 16, that's 16 hexadecimal, and you add the offset. This is the offset inside the segment. What do you get? Well, you get this transposed with a 0, and you still have to add this to it, and I have absolutely no idea how much is that, so I'm just going to run a calculator and calculate it, because doing math on stream is hard. So that's 0 plus 0xFFF, and we can do hex on that. Yeah. So this is this amount. Now, which is a little bit over like 1 megabyte. It's like 1 megabyte and 64 KB, a bit over. Now, by default, actually, no, let it be like this. This is, by the way, 20 bits. 20 bits of space. And by default, the older x86 at that time had only 20 bits of address lane. The address lane had bits from 0 to 19 to express which address do you want. But this address obviously is like, it requires at least 21 bits, the one for this one here, right? So what do you do in that case? Well, you don't do anything, because there is no lane to express that bit, which means this address is actually the same as this address. Now, on new computers, like 286, 386, and so on, that Intel released later, or rather new CPUs, you suddenly got, well, for 24 actually bits of address lane, which means you could suddenly address this, but people already created software which used this denotation with the 1 here, like using this segment, to address the memory which is at the beginning of the address space anyway. Which means, yeah, if you suddenly add a new bit lane and a new address line, you crash that software. It stops working. So yeah, so that's where A20 came to be. A20 is the address line number 20, and by default it was tied to 0, disabled, and you had to ask BIOS to actually turn it on for you, so you could use more. Well, you would not have it tied to 0. So I hope we will not have to deal with any tricks like this, because there is no A20 in 83, no A20, and I hope like BASIC didn't do anything in the upper parts of the memory. Usually programs at that time only touched the lower parts of the memory, so I hope that's the case. Yeah. So yeah, this is something we also have to take into account here, that this code actually uses segments, and it can use this weird stuff. On top of that, I did mention the API of BIOS, of video BIOS, of DOS, right, of the disk operating system. What I didn't mention is so-called MMIO, which is memory mapped IO, as in input and output. What does that mean? That means that some devices had some special magical addresses in physical memory, had then and have now actually the same addresses in case of some devices, where you can chat directly to the device using just memory. So you just do move to chat with memory, or you do push, which actually writes to that given part of memory for some reason, and you interact with a device. It doesn't look like anything in the code, but if you know that the device is actually mapped there, that's actually interacting with the device, like changing the resolution or actually putting data in the frame buffer. That's usually how it was done. You'd either call a BIOS API, or more frequently, if you wanted some more performance, you would just write directly to the video graphic card mapped area and directly into the text frame buffer. That frame buffer for VGA, it was on the address of 68000, which can be translated to, sorry, is that B8? That's B8, obviously. That can be translated to like segment B000 and address 8000, or it can be translated to like this and address 000, whatever you like. Because again, the segments overlap, so we can choose one. Yeah, and like to this day, you can find a frame buffer, part of a frame buffer on this address. Yeah, it's still there. Now, yeah, so if we actually find that the application is trying to chat with some weird address in memory, we have to take into account that it's actually trying to chat with a device, with some device. The device would usually be just the graphic cards, actually. It would not chat with a disk controller or anything like that. That way, it would leave it to the operating system. I'm a little bit wondering what this x8656 is. If we go to, let's go to ginveil vexillium org /dump/opcodes.txt, then I did have some 59, that was 59. This is 32-bit, and we are looking at 16-bit code, but I want to find that 59 because I think it's a prefix. Where is it? There is no 59, so that's probably a prefix. Let me double check it on Intel Manual Vol 2. At the beginning of the second volume of Intel Manual, there is an amazing section about like segment addressing, but yeah, this is what I'm looking for. This is how a 16-bit instruction is being created, but there are the prefixes which I'm interested in. No, CS is 2E. 2E, what is 2E? 2E is 32 plus 14. So that's 46 now. So yeah, so I have actually no idea what is this 56 here. Is it decimal? What is it? It says CS override. Is there a 56 here? There is no 56 here. How? Okay, hexadecimal 56. Maybe they written it in decimal for some reason. 3E is not here. Maybe they have written it in octal. Octal would be 2E. 2E. Okay, so this is octal, and this is a trap. Like, it's good that we checked that this is octal. It's not decimal, it's octal. We have to remember that it uses octal system by default and not 16. and not decimal system. So yeah, we get 5e, and as you can see, 5e is actually a CS segment override used with any branch instruction is reserved. Okay, so what does that mean? It means that the next instruction, which is this one, which is like read from the bx, from wherever bx register is pointing to, that actually means read from the CS register, sorry, from the CS segment from the bx register. Now, if you're not familiar with, again, the segments, then there are a couple, like 5-ish registers, segment registers, which can point to one of the segments. In 16 bits, this is just like treat them as 16-bit pointers, basically, to a segment. It's way more complicated than that. Let's not go there. Just remember it's a 16-bit value which points to a given segment, which is a segment selector. Again, this is way more complicated when you start digging into the details. Yeah, so it just means that the next instruction is actually CSBX. Yeah, so we have to remember that this is octal oct, which is crazy, but okay. So what I think here is that this, it just means emit the next byte. It's like, what did I press? My take on it is that it will just do, so ins 86 is probably going to be the same as db now. So just emit a byte, emit the byte 56. So yeah, this is what I'm reading it as. I might be wrong, we might, but it's a valid hypothesis. Okay, there's a good question. If we have to override this, right, then what does this instruction use by default? By default, move instructions will use DS, which is data segment. Then optionally, it might be ES. ES is the extra segment, or whatever you want to call it. There is also SS for stack registers. And for example, push. Push CX puts something at the address of... push will push the CX to the address of SP. But SP is like, which segment is that? Is the stack segment. So that's actually SS SS being the stack segment, SP being the stack pointer. And it's kind of convoluted and kind of not intuitive, but most instructions in the documentation say what is the default segment they are using. Most of the time it's going to be DS. Jump instructions will use CS because they operate on the code segment. CS is for the code segment. And otherwise, the stack instructions will operate on the SS, which is the stack segment. And the ES is used in some cases. I do not believe we'll find ES used here. There are also two other, like FS and GS. But yeah, we might find them if like they are using them manually for some reason, but you have to use an override instruction in their cases. There are no instructions which operate on FS segments or GS segments by default. Cool. Okay, so what is very weird about this code? Low. What is low? I have no idea what is low. Or low 96. Why is it low? So yeah, I have no idea what's that. Does it mean that this immediate value is by default, I don't know, like for example 16-bit, and then they use low to actually just get like means grab bottom 8-bit? But might be it. That's how I'm interpreting it. It might be something different. Okay. Then there's offset, neg-d. What's neg-d? Okay, yeah, I'm pretty sure now. I'm convinced that ins is going to be just emit a byte. Now this, what is this? It says is neg the x, dx. Let's translate it into some... I do not consider octal to be normal. I know for a fact that Back in the days, in like the 60s and 70s and early 80s, they used octal instead of hexadecimal. I do consider hexadecimal to be normal now. Yeah, so that's decimal, this is hexadecimal, and 332. So the bytes there are actually F7DA, and I guess we can check what is that. We can check using this list. Again, this list is 32-bit, but most instructions in 16-bit are also in 32-bit on the same opcodes with some changes, so that's F7. F7, yeah, that's probably this one. Did they say, negate? Yeah, they say neg dx dx, so this is probably this one. And DA being, in that case, well, dx as they say. So this means that their assembler did not support some opcodes, like some mnemonics for some reason, so they had to like just emit it manually for some reason. Well, this doesn't look bad actually. We could even throw it into NetWide assembler with some stuff. Now this is a little bit more interesting. What's going on here? We have a dseg data segment. And then we have some external value. This is a global variable declaration basically. We switch into the segment, the data segment. So that's like a linker would put it totally in a different place than we see it in the code. The linker is going to grab all the sections, all the codes which are in the same segment together and put them somewhere else. And this is true for modern assemblers as well. We are using more sections than segments, but whatever, same stuff. And okay, and when the section, the data segment is supposed to end, and we create what? Another extern here. I have no idea what's that. Okay. Yeah, this notation is pretty nice. This is what? 73. Is that O? I think that's O, but it's not a 0, that's an O. So, octal O. 73 is 59. Let's do an CHR of that. That's a semicolon, everything works. So that's also not bad. Yeah, this code looks pretty decent. Now, what we saw before was also something called call OS, and I'm pretty curious what is that. rgrep call OS. Okay, so it says that it says it's the binary files, by the way. These are not binary files. They have some weird characters at the end, but these are not the binary files. And ms-u has this call OS macro, so we can take a look there. Wow, there's security MD. So reporting security issues, really. Okay, no, that's probably like a boilerplate text. 82, okay. So we have this macro. What's going on here? Oh, it uses 33D. What is 33D? That's 21, right? Yeah, that is like, let's do hex 33, that's 21. We can see there that we are using the D as a suffix for decimal. And we are using sometimes O and sometimes not using it for oct. And I guess we are not going to find any hexadecimal values. So yeah, we must remember that this 5D is not 5D hexadecimal, it's just 5 decimal. Then we have some codes. Okay, so it's pretty nice in that case because it seems it's not using a lot of this call OS. Let's actually grab over int. I'm quite curious how many int stuff they have. I'm actually going to go for an int with a space. Okay. I'm going to actually go for int with a space on both sides. Not a lot. Or is this not a space? This is probably a tab, right? Yeah, it's a tab. So let's just do this. Okay, there's some like how can we tell our graph to just display binary files? Okay. Can I do like text or something? Dash A. Okay, let's do dash A. Oh, here we go. This is using an ME as this. Wow, that's actually pretty cool, because we are almost not using anything. This is probably hidden behind the macro, because CPM x86 is a different operating system than Microsoft does. Yeah, so I think there are 3 files which are actually, or make it 4 files, which are actually talking with, which are actually talking with the operating system. So that's actually super nice for us, because that means we will not have to find like everywhere in the code base, like each single API call. We just have to probably tweak a couple of files, which is great. Okay, now another question. Let's go to Wikipedia. It's a little bit dark here. Let me fix that. Okay, here we go. Wiki GW basic. What I want to know is if this is if this was an executable file or if this was a .com file. What's the difference? The difference is that executable files had segments and sections, and COM files had okay, Microsoft distributed GW basic exe. So this is an executable file, which is a little bit more complicated in structure than the COM files. It doesn't come close to the modern executable files, but that's fine. Okay, so now another thing is, what about the macros? How many macros are there in total? What is this func? Is this func a parameter, like an argument? It looks like an argument, right? Let's do grep over macro. Yeah, there are some macros, not a lot of them. Because, why am I checking it? I'm checking it because, like, on every assembler has a different language for macros. Which means we would have to probably translate the macro to a different assembler. And there are some macros, not a lot of them, but there are some macros. Let's do grep dash A1 dash B1 to see what's next to it or before it. Okay, so it's the macro name. Can we do dash 2? A and B is like before, lines before and lines after the match. This doesn't look bad. What is this Z80 thing? Okay. Yeah, it doesn't look too complicated like the macro language at the end of the day, I would say. It has like some parameter insertion, some like additions and resolution, but that's not bad. Okay, what is this? File data block record. Offset, what is this? Okay, it's a macro which is defined at the beginning somewhere. Oh, is this one? Is the name and then the offset plus offset. Okay, so it's just like some iteration. Oh, that's cool. Okay, so this doesn't look too bad. Let me take a look at some random other files, or actually go one by one. Is there anything super weird here? What's the name of the file? Advanced GRP. Generalized graphic stuff. I like how they actually use stuff in here. Why is there graphic stuff here? Because Basic actually allowed you to draw things. Okay, doesn't look super complicated. Okay, where does it draw actually the stuff? What segment does it draw the stuff on? Let's look for put pixel, that will tell me a lot. Like some kind of paint. Call something, then something. Init paint. That's weird. Can I just look for some put? I think there is like a. Is there like a draw? Draw a circle. That's perfect. Okay, circle. I have absolutely no idea what's going on here. Move our. That's some kind of a macro. Then it uses calling. Okay, so why is there, like, we saw in macros some floating point math macro, and like here we are calling some floating multiplication. Why are we calling floating multiplication instead of just doing floating multiplication with an instruction like fmul or whatever? Because up until, what was it, like 486? Or yeah, 486 DX, I think, the CPUs did not contain the floating point unit. You actually had to buy another chip and put that chip on your motherboard, and that would do the floating point math. Otherwise, you'd have to do it in software. And that means that, yeah, they did it in software because back in the days, there was no, like, they couldn't assume that it's actually installed on the motherboard. That's something you had to pay the extra, basically, to get it. But what I'm interested in is how does it actually put the pixel there. Huh. Set up plot polarity flag? What's going on here? Okay. Frame VL. Make it floating point. I honestly have no idea what's going on here. Spreads. Okay, is this drawing with like monochrome drawing? Yeah, the graphic cards might be funny. But it might actually be it, like this part, which is referring to memory, which BX is set to FAC. FAC, what's FAC? It's an external word, okay, perfect. It might be something else though. Like some factor? Okay. Yeah, this is interesting, this is going to be a pain though. BI boot, initialization file for, okay. There's a problem running blah 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 sources for basic as they stand. Microsoft just puts 100 hex byte control block at the beginning of the exe file and sets up the S register to point to it. Basic, however, expects this block to be at 0 in the code segment. The quick and large instructions to copy. Okay, wow. What kind of hacks do they actually have here? Oh well, if we have to deal with this kind of stuff, then this is going to be problematic as well. Okay, what is this doing? Sorry. Basic interpreter, miscellaneous routines. This is probably not doing anything interesting. Then we have .h, which has some macros. LXI. I don't think there's an LXI instruction on x86. LXI, no. No, there is no LXI, so that's pretty weird. Okay, what's going on here? Okay, these macros look rather weird. Basic interpreter print using driver VHG, whatever VHG is. Okay, call x86. 8086 call statement. Why do I have a file for that? Don't allow call as direct start. What is going on here? I honestly have no idea what is this. Okay. This is called simple var strategy. Make sure strategy. Okay, strategy. The strategy is to make sure subroutine name is simple var, get value and save it, evaluate parameters and staff pointers on stack, call subroutine. The call statement is same as call, except for each parameter is it pushes segment and offset, not just the offsets. Okay. Okay, I don't know what this is, but this looks interesting. DSK.com. Common routines for disk basics. Okay, that's fine. We don't need it. Fivel, what's that? While call channel Paul Allen. Okay. No idea. Gen GRP. Generalized graphics. Okay, so I guess this is not the advanced graphics which we were looking at before. Push text pointer. Doesn't look anything magic. I'm basically looking for like weird stuff right now. Let's take a look here. What is like PC? Oh no, this is just okay. Yeah, doesn't look bad. What's the difference if they put like this auto or data or this? Does this $sign actually change anything? Okay. Kanji. What do we have here? Kanji string function. Kanji is the Japanese alphabet. One off. And there's nothing here. Because it includes GIO x86. Do we have this file here even? GIO, is this one? No, is it this one? Oh, maybe it was the previous one. Okay. Okay, it doesn't look so bad. So okay, how do we approach it? How do we actually compile it? How do we link it then? So there are three ways as mentioned, right? And one way is to basically regex the hell out of it and change every line to be compatible with NetWide assembler, and then compile it using NetWide assembler. What do we link it with later on is a different question. I have absolutely no idea how do we link it on later. What does NetWide assembler even support for like output of 16-bit targets? I don't know. Help. HF. Okay, so these are the valid output for what I have. Bin is a flat form binary. We cannot have bin. because we cannot have it like this. Yeah, it's problematic. Because even Intel hex or like whatever else they have here, it just maybe object would be good. Maybe we can actually compile stuff to object, and then we are missing a linker in that case. And in that case, we will have to find something that links OMF files, or something that or write a linker, which is another idea, obviously. We could write a linker as well. Let's grab some file, an easy file. Is there an easy file here? Like, okay, let's take a look like that. Let's take a look. What is the shortest file? This one. What is in that file? It just does two includes, which makes it actually super long. Doesn't make it short. Okay, call this one. So this one is a weird call. It does include OEMH. Then it has the segments. We can translate them easily to sections. Yeah, so maybe we can. I think it's actually a viable strategy to regex the files and make them compilable by using NASM. NASM is pretty cool, and it would give us the obj files, the object files, which then we would have to figure out either to grab a linker, which will link it for us, or write a linker for ourselves. This is a little bit a pain, but that's one of the options. Another option is obviously to find the old assembly they were using from 83 and just run it, but that sounds boring, so let's just not do it. And then we have third option is to write a custom assembler and a custom linker in Python. And by custom, I don't mean fully custom, but just like probably would have to implement like the macro language and use like Keystone? Yeah, Keystone engine for the assembly itself. Which I'm kinda leaning to, though I'm not sure if that's not more pain than just using NASM. Then the next option is to write, like technically we can write an emulator for it actually. Like there's nothing stopping us from writing an emulator which would not emulate machine code, but would emulate mnemonics, like the text form of assembly. And then the emulator would actually like get one line and yeah, like for example this line, then take a look what is this, like save sec, replace it, and then run push. There aren't that many instructions on this platform, so yeah, we could easily do it, but we would have some issues with stuff like this. So I wouldn't want to go that way. Another thing we could do is we can try to write an assembler again for it and a linker, but no, actually just an assembler, and translate everything to Python, which is like a middle ground between the emulating the assembler itself and actually I guess like compiling it, or rather writing a full assembler. Okay, let's think about it, and for now I'm going to take a look at questions. So if there are any questions, if you have any comments about what I said or which way would you want to go, then do type exclamation mark Q and then your question or your comment, and we can take a look. And now they are going to appear here and I'm going to take a look. How can we approach reverse engineering object-oriented programs? I think the same way, give or take, as normal programs. From a reverse engineering perspective, the difference isn't it's not a huge difference from reversing a C program, which is written in a complicated way and an object-oriented program. The things which you need to remember is that one of the parameters which is usually transmitted in a weird way in some weird register is going to be the this pointer, and then each object is actually just a structure, so you will have to reverse engineer. By analyzing the code, you will have to reverse engineer the structure and all the fields. And the third one is that if there is inheritance, and especially multiple inheritance, you will have to deal with and virtual tables as well. You will have to deal with virtual tables, which is basically on top of the structure, you will have also another structure which has only function pointers to some of the functions. All the other functions will be like normal functions, just will take this parameter as the one of the parameters and will operate on the structure. So the difference isn't that big, actually, surprisingly. I would say, like, looking from an assembly perspective, the difference isn't that big. You do have to get used to it, though. So yeah, just do it normally and get used to it. How important is getting a PhD in computer security when the final goal is to work in the industry? Not important at all. At all, seriously. Unless you want to work as a, I don't know, like crypto, and I don't mean apply crypto, I mean like actual real crypto. And okay, applied crypto is real crypto, but I mean more like crypto analysis and creating new cryptographic algorithms. Then you might figure that you might actually want to get a PhD in that and mathematics and whatnot, and in crypto. But for any other security stuff, I do not believe PhD is required at all. Just get like engineering degree or like masters and go to the industry. Yeah, like actually staying in academia for a long time, if you want to work in the industry, is a little bit a waste of time. That's my opinion. Like, feel free to disagree. Absolutely. Okay, I already commented this one. There's a link from KrzaQ about the CGA. Yeah. This is what I was thinking about. This is absolutely amazing. I'm so forwarding you folks the link. This is absolutely amazing what we are writing here. I did read it back in the days when it was published. Thank you, Chris. Good link. What book do you recommend to understand malware? I don't know. There are a couple of books which are about malware analysis. I did not read any of them, so I have no idea which one I could recommend. So I don't know. Like, the best way to understand malware is to reverse engineer malware. That's my opinion. You can, yeah, I think that's actually a better approach. Like, learn some basics of reverse engineering, then figure out how to reverse engineer malware securely and safely, because that's basically do not run malware unless you know what you are doing, and you're doing that on a virtual machine which does not have access to your local network or your local machine at that. Yeah, and reverse engineer malware and play with it. With most malware, it's not hard at all. And after doing, and even you can do it, you know, with, you can start with JavaScript malware or like Visual Basic malware or whatever. Yeah, and after that, read the book. That would be my suggestion. So that when you're reading the book, you already know something about like malware. And look at like stuff which is published by malware researchers. Like, take a look at their blog posts. That might be really, really interesting. And yeah, I know Hasharazadeh published some stuff. You might take a look if she published anything in that direction which you're interested in as well. Disconnectorize, does it mean the ins86 instruction says which segment register to use? No, well, that one specific, yes, but in general it was DB. So in general it was that instruction which we looked at, which was like ins86 like 56, I think. It was just emit a byte 56 octal, and that was actually a prefix to like which we found here, right? Yeah, it's actually on the right page. yeah. See, where's the prefix? Yeah. Oh yeah. This was this byte basically emitted, which can be placed before almost any instruction and then acts as a segment override. In 32 bits, like knowing this stuff was pretty useful. In 64 bits, we are basically left with two segments, and they are used. Well, one of them is usually used on both Linux and Windows, but they are pretty used only for special cases. So we are currently operating in flat mode. We do not have to care too much about this. The segments. One side story here about this is that back in the days when the CPUs did not have VTX, which is like virtualization, and you could not run virtual machines as easily as you can do it now, you had virtualizers which were basically like emulators running, well, x86, right? And one of the games was how to detect such a virtual machine. Like, how does a virtual machine know that it actually is running, or rather, how a program knows that it's running on a virtual machine? And one of the tricks we found was that if you put enough of like these prefixes, so like if you would put 2e, 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 blah blah blah, 2e, and then the actual instruction, which could be like no op, right? Then it would crash on a real computer, because on a real computer you have a limit of instruction size, but on a virtualizer like Microsoft Virtual PC, it would work. So yeah, if this crashed, it's a real computer. If it did not crash, that's a Microsoft Virtual PC. Yeah, such a like funny unrelated story. Okay. Oh yeah. Disconnected writes that grep-ax-bx can be written as grep-cx. Okay, I didn't know that. Thank you. That's a nice trick. So writes, Ken Thompson wrote assembler, editor, and Unix in 3 weeks. So you can probably just write assembler in 1 week. I guess if I would have time for that, yeah. Will there ever be OpenCL? No, I don't think so. Yeah, basically, like, it's like this. I'm doing live stream topics of stuff which I do not have to prepare for. This is either because I know them or I have recently learned them. And I didn't play with OpenCL much yet, so yeah, so there we are. I don't expect it to be there anytime soon. Okay, so what do we do about it? Let's actually do a vote, I think. How many folks on the chats currently would prefer to just like compile it using NASM? So type NASM on the chat if you want it to be compiled using NASM, and a set of regular expressions. So as NASM rules like regx, but just type NASM. If you want to do to transpile it to compile it into Python, then like just write Python. I think these are the two options which we could do. Yeah. Okay, I'm going to give you a couple of minutes. I think it's going to be pretty tight, actually. If this was a CTF, which option would I choose? If this was a CTF, I would compile it to Python due to it would be easier to debug. Okay. Okay, yeah, this is going to be close. Okay, let me count. So 19 for Python. And 11 for network for doing regexes to network assembly. I think we are going Python, folks. So what we are basically going to do is we are going to try to translate this code into Python files and then run it, basically. Yeah. It's going to be funny. It's not going to be fully Python code. It's going to be weird. But yeah, okay, let's just do it. And yes, although absolutely, if we are, yeah, if we would go for regular expressions, we would have some like more problems. I would love to I would love to learn how to make an assembly. That's another comment. We will be kinda doing part of an assembler anyway. Okay, cool. So what do we need to write first? We need to write first something which understands this code, which grabs the file, and then we basically need to write an assembler. That's what I'm trying to say. It's not going to be a full assembler, but it's going to be close to it. So yeah, this is the first point, right? An assembler, something which reads this, takes the data, and gets us and puts this into structures which we can then play with. So this is going to be the first step. The second step is going to be try to determine if we can split the code into functions somehow. This is not going to be easy though. Because like, you know, when I'm thinking about it, it's like these jumps here are going to be a pain in Python to implement. Oh well, I think we will end up with something in between actually at the end of the day. Oh well. Yeah, we have to write basically a parser anyway. Now, are we going to write the parser today? I guess we can start with it. I'm not really sure how to approach it yet, so I'm going to write only some basic code today. Basic code. Yeah, sorry. Pun not intended. And after that, I'm going to try to... okay, let's just go with parse.py. And after that, I'm going to think a little bit more what I want to achieve. But regardless of that, we need a parser anyway. How are we going to write a parser manually? Obviously, because why wouldn't we write a parser manually? Radix 8 to be safe. Okay, so yeah, now we know. Does this actually is at the beginning of every file? Yeah, this is at the beginning of every file, basically. Okay. Then we have, how many segments do we have? Can we actually, are there only 2 segments? Are there only like data segment? And let's grab for segment. Okay, code seg, data seg, code seg, data seg. Let's do -a again. See, code seg, data seg. I think there are only 2 types of segments ish. Cool, that's good. Okay, so boilerplate code. Let's start with include, right, user bin Python 3. And now we need a function which basically grabs a file. Let's call it just parse or process, and we get a file name, and then it does something with a file, and then we need to run this file on like import glob dev main for fn in what directory are we in, by the way? Qbasic master. So let's take this one. Glob basically lists a directory ish, kinda. Print file name. We will have to not use some file. Let's do this. Question, rgrep equals grep-r. Yeah, true. Or is it capital R? I don't know. But I would, yeah, I'm usually writing rgrep because I'm lazy. Parse F9. We will actually make a list of files, I believe, because not all files are going to be processed. So Python 3, get out of here, Python 3 parse. And nothing happened because we did not code main. If name is main, then code main. F name is not defined because this needs fn. Okay, we probably need only asm files. If we will need any other files, then we will take a look. So .asm. Okay, now we have only asm files. Perfect. So first, open the file. This is Python 3, right? This is going to be a pain. What kind of encoding is that even? I don't know. So with open fname read. How do I set the encoding for a file on Python 3? Python 3 not read, open. Buffering encoding. Okay, we need to set encoding for some weird encoding. Like, what encoding was used in, like, wiki IBM 439, 437? IBM encoding. Not this one, absolutely not this one. Code pages, perfect. 417, I think that was the name. 4110, no. Or was it 700? Am I just... 437, 437, this is what I was looking for. Yeah, let's use this one. I have no idea if, like, let's see, Python 3 encoding, can I just use 437? Because that's a pretty standard encoding, I think we can. IBM 037, we need 437, yeah, CP 437, 437, yeah. Let's just use this. That way it will not complain about weird characters which are non-Unicode. And now we can just read the file, so like lines is equal to file read and split lines. I'm going with split lines because read lines actually leaves the end of a line marker and we do not care about it. So yeah, print this and length of lines, how many lines are there? Yeah, quite a lot of lines, perfect. It seems OBS disconnected, so it's a perfect moment for me to grab some water. Yes, drinking water is a perfectly normal human activity. Cool. So, yeah, now I'm actually going to do a break here so that we only process one file. I would actually prefer to process, this file is weird. Let's start with this one, like GW something something. If fn ends with, then parse, otherwise, like, yeah, this is like temporary remove me later. Okay, now we are only parsing this file. So let's take a look at this file. What do we have there which is weird? Yeah, the drinking water is a perfectly normal human activity. That's a joke, by the way, from the internets. You might, yeah. You might find the source of it. Okay, temporary. Again, if you have any questions, you have to type !Q and then the question, but it goes to my panel on the right. Sorry, that was GW main. Okay, what do we have here? If there is basically anything after a semicolon to the end of a line, we do not care, so that's a comment. Oh wow, there's also like this comment here, which is a multi-block comment, multi-line comment actually. Okay, then this like doesn't matter, we can just strip the line. So let's do it like this. We need to, again, I'm writing boilerplate code today because we have to finish the live stream in 30 minutes anyway, but we will continue on the next stream. So I think I'm going to write some code for like a couple of more minutes, and then we can do some questions and we can end the stream. But yeah, the first thing to always do is we process all the lines, so ln and lines. We do a strip. A strip basically removes all the white spaces from the beginning of a line and from the end of a line, if any. Then we can check if not line, which is the same as if line length is 0, if not line, if line is empty. Just continue. We do not care about this line, otherwise do print this line because I'm quite curious what do we have there. Okay, and we get the lines. Perfect. And we go line by line, basically. If the line begins with, so we can also remove lines which begin with a semicolon, we do not care about them. That's kind of a special case, but what we could do actually here, so yeah, okay, no, I cannot do it now, because what I need to do first, I'm wondering if there is anything else like a comment, like for example a text block which spawns for multiple lines. How can I check that? I can check that by doing an rgrep with an asterisk. And dash a as usual. So yeah, we have this comment. I'm just wondering if I should just, let me just like do grep -v, which means exclude everything which has a semicolon, because that does not help. Okay, we have comments, then like some lines with asterisk, was fine, comment, and get ignore. But there doesn't seem to be anything like string and an asterisk, so that's fine. Okay, so I guess what I first need to do is I need to find a line which starts with a comment. Hey, actually, okay, the other way around. Is there a comment with without an asterisk? Comment equals, no, that's not the, what? Okay, no, that's fine. This isn't comment, this is like comment revision history. What's going on there? Sounds interesting. Revision history. Okay, so this actually explains a lot. Comment, the next character after comment, is going to be a delimiter. And after we look for that, an empty line with that delimiter, and this is where the end of a comment is. So it doesn't have to be this, like an asterisk. It can be anything. Perfect. Yeah, we can use that. So let's do that. What can we do? I'm wondering about splitting the lines, but I'm a little bit worried about splitting the lines so early, because then we will have to deal a lot with this kind of stuff. And splitting by a space is not really going to help me too much. I guess what I'm going to do is I'm going to check if we get a comment with a but this doesn't have to be a space, it can be a tab. I'm wondering how much processing should we do now? Okay, Python split. What can we tell about Python split? let's do A space B space, no, B tab C. And let's do a split here without any parameters, and perfect, it does it on the white space. Yeah, so it includes tabs, it includes white spaces, that's perfect. So I can do a split. Okay, I'm going to probably do a couple of types of processing, but let's do like first like white space separation for some stuff. And yeah, we're basically getting tokens are equal to the line, which is going to be split by white spaces. But we are going to filter it. So we are going to put any token for token in the split, which is the same thing, but we are going to ignore empty tokens. So if token, yeah, that means if token is not empty. And we get tokens, so we can print the tokens, actually print the line after that. And what I would do here is I would do here like something like this. So we can kind of know what... yeah, we are doing manual parsing because I'm too lazy to remember how to do it properly. Why are there like some zeros at the end of a file? What's up with that? Should we include actually strip to like remove zeros as well? Anyway, what we care about now is we care about the comment. Because we need to remove the comments. The comments are not going, they do not influence the code in any way, they are just not important. You know what, I'm going to do something else. I'm going to do enumerate lines, and here I'm going to do I. And let's only focus on the first, like if I, on the first 50 lines, and then break. And like, yeah, like remove me temporary. Cool, okay, now we get the comment and we get it nicely parsed, so we can check here. If, can we actually assume that the token is going to be at least, that there's going to be at least one token? Yeah, we should be able to assume that, yes. So if tokens of 0 is equal to comment, they are all capital, right? I hope they are like, are we like, okay, let's do it like this. Grep for comment, and let's just count them. No, let's do it like this. And now let's do -i. -i is case insensitive. What do we get for case insensitive stuff? Do we get anything more? We get git ignore, and we get like, or, yeah, we do not care about that. It's fine. It's always capital, which is good. So if it's comment, then we get into comment mode. Multi-line. Comment mode is false. And multi-line comment delim, what's a delimiter? If it's a comment, in that case, if by the way, I'm not going to do almost any error checking. Why? Because we have a input sample which we care about, which is the files, and we do not care about anything else. We care only for this to work on this one specific project. Okay, then yeah, then multi-line comment is true, and the delimiter is whatever the tokens 1 is. Do we have to do anything more here? No. And therefore, here, if the multi-line comment mode is on, then if tokens of 0 is equal to the delimiter, we actually turn off the multi-line comment mode. False, and we can, yeah, defensive programming, but whatever, we can change it to none. And we just do continue, because this line is finished. Cool. Otherwise, what do we do otherwise? We just continue. We just continue because it's a comment. But before we continue, I'm just going to put like multi, like just to check and not continue actually. Okay, let's take a look. We have a let's take a look at that file. Actually, it's gwmain.asm, and here we start with, we have radix, then we have, it says empty line, but it's not empty line, just continue there. So this is the comment line, which is here, this is this one. Then we get a multi-line comment, another multi-line comment, another, up until this is Monte, the last one. Then we have an empty line, which is absolutely ignored, and we get this delimiter, which again doesn't print out anything, and we get off the multi-line comment. Okay, it seems to be working. So I'm just going to do, instead of this, I'm going to do this. Okay, this is fine, so yeah, just do this. And we are absolutely ignoring everything now, which is perfect. So that's one thing. The other thing which we can ignore from the beginning is, I'm a little bit, what I want to do is I want to remove everything in a line from the end to the first semicolon. And I'm a little bit afraid of cases where somebody is doing like this. Yeah, and then it would like find me the semicolon here and remove everything here, which is absolutely not what we want to do. So that's why I'm a little bit worried about doing that at this point. We can actually look if there are any cases like that. So let's grab for, yeah, this is like a lot of semicolons, obviously. But I want a semicolon which is between these two, between two quotes. Yeah. And do we have any semicolons? Yes, but like, this is not what I meant. Is there a semicolon between two pairs of characters which are not quotes? So, yeah, characters which are not quotes in 0 or more cases than a quote. And yeah, well, that still matches, obviously. Anyway, yeah, here. It's there anyway at the end, like the last line. So yeah, we cannot do that hack. We cannot do that hack unless we actually count this as well. Yeah, I don't want to deal with it yet. I will deal with it later. Okay, so yeah, we are dealing with comments. So I am going to add a quick hack here, like that. If ln starts with a semicolon, then just like ignore it. We don't care about that line, seriously. I would prefer to have a general solution which also like removes the comments from the end of the lines, but we are not able to do it yet. We will get there. Okay, now it's a bit better. Okay, now what I can do, again, as like thinking, hey, can I just go for a token which is like remove everything until a token which is a single semicolon? No. Why? Because, well, this comment here is also, yeah, it's just not a single semicolon. So no. We'll figure it out later. Okay. Gary writes, how hard, I'm going to take a look at the questions for a bit. So Gary writes, how hard is it to write a transpiler versus learning a new language, a dead one? Well, it's always easier to learn a language than to write a transpiler, I would say. Yeah, just because like in transpilers you will have to deal with a lot of weird edge cases and a lot of weirdness, and you have to know both platforms quite well. The one like the source one and the one you are compiling to. yeah, and when learning a new language, you just learn the language and you do not have to care about everything. So yeah, it's always easier to learn a new language. Hi, how many programming languages do you know and which? Okay, so I don't know if I know any. I can program quite fluently in C, C++, Python, JavaScript, and assembly x86. I have written code, quite a lot of code in, let's say, 5, maybe 10 other languages, and I've written some code in 20 more languages. So, yeah. But again, I'm not sure I can say I know any of them really, like, from A to Z. I can hold my ground, but yeah. If I get if for example I discuss C++ with KrzaQ, my today's moderator, I feel I don't know anything about that language, even though I have 18 years of experience of C++. So split by a semicolon to get rid of the comments. No, because it will also destroy this case. This case, you don't see the screen. I apologize for that. Yeah, here, because the split would be here, which would be weird. So yeah, no. We will have to be a little bit smarter about it. Are you sure that that the token is always only one character? No, but I don't care about it because I here, right, when I'm doing the delimiter setting, this does not mean take the first character. It means take actually the second token in the full. So yeah, it takes the whole token. It can be, even if it would be like comment ASDF, then it would still work because this would be the 0th comment and this would be the first comment. And I'm taking the whole first comment and I'm putting it as a delimiter. So it doesn't take just one character, it takes everything. What is the data on the 38 page of paged out episode 2, issue 2 actually? Do you know the solution? The data appears to be 4 gzip files spliced together 15. You mean, oh yeah, that one. Now let's go to paged out for a second. I think I know which one you're talking about, but let me just open the magazine for a second. You said page 38. This one. Yeah, it's... I know the solution because whoever made this advertisement actually disclosed the solution to me. And I know people solved it. And I know it's a pain to solve a bit. There is some guessing involved, I would say. So yeah, I'm not going to spoil it, but basically you are free to discuss it on our Discord on the challenges channel and try to solve it together. I know there are some people who actually already solved it. Yeah. But I know it's a pain. I tried to solve it manually for some time, and yeah, I run into issues as well, so perfect. Let me take a look here. Okay, then what do we do next? Okay, if there are any questions, let me know. Just type !Q with a question if you like. Now, what do we do next? Okay, we can... This radix actually works pretty well. I'm wondering what to do next. Because there are a couple of ways to go. We probably could... We'll probably have to write a parser. Like a little bit more proper parser than I'm currently having. And the parser will not be able to split by... Yeah, we just have to write a parser. like a normal parser, which doesn't do weird stuff. If you're thinking, how am I going to do this? I'm absolutely calling Python evil. So evil is the proper pronunciation of that function, by the way. It's not eval, it's evil. Like, yeah, you know, like the evil word. Yeah, okay, so next time, what we are going to do next time, we are going to write the semi-formal grammar for this stuff. And we are going to translate that semi-formal grammar into Python recursive parser. And then we will get a nice list of tokens, which we can, with types probably, which we can play with. And then we are going to take that and we are going to start translating it somewhat into a list of stuff to metadata on one side, and on the other side of actual code which carries some execution power with it. And yeah, and then we'll figure out how to get, like, from each file, get the metadata and so on, and then merge everything together, and then how to execute it. So it's going to be fun, but that's going to be for the next week, because again, I do not want to overrun with today's live stream, because SpaceX is having a nice live stream after this. So if there are any questions right now, I'm going to answer them. Otherwise, KrzaQ was my moderator today. Thank you, KrzaQ, for being here. And thank you, everyone, for being here. I'm going to stay for a few more minutes to do the questions, and then we meet each other next week, and we are going to continue with this little fun stuff to do. I do expect the next week to just, like, we should be able to finish at least with the parser. That would be pretty nice. Okay, so the questions will appear here, and the question is, how did you start out with Python? Is there a story? Good question. I don't remember. It's like, I think there were some friends who were coding a bit in Python, and it was the time where you either choose Perl or Python when going forward with a scripting language. I'm not sure scripting applies anymore to Python or Perl, but whatever. And yeah, and I went with Perl. I didn't go with Python, I went with Perl, and I've learned Perl quite decently, actually, and I've written quite a lot of code in Perl. And then I decided, hey, Perl, let's take a look at Python, and then I started learning Python. So I think that's the only story there is. And Python is quite easy. I like Python. It was always pretty easy to read. So yeah, there it is. Is there Python 4? Good question. I don't think there is a Python 4 yet. There might be some ideas and some discussions already. Sometimes, like, the committees of languages like to plan ahead, like, really far, and think about, like, hey, like, Python 5000, what features would you like there? We cannot add these features now because, like, a lot of stuff is relying on backward compatibility, but if we would do like super modern version, what would it have? So maybe there are some ideas. I would take a look actually on the PEP side of Python, where all the proposals for languages are coming. Okay, maybe you can solve the challenges someday. You mean like on the live stream? I should solve the challenges which are being posted on the challenges channel. I know you created quite a lot of challenges from there, so maybe that would be something we could do. Yeah, makes sense. Okay, are there any other questions? No, I think that's it. So perfect. Let's finish it today. And oh, there's another question. Did you play the hack the SAT qualification? So hack the SAT qualification was a pretty, how do you say, it's not well advertised, but like everyone was talking about it. Like, it was the new hotness, basically. Hack SAT. Is it? Is that it? Yeah, that's this one. And Well, the qualifiers were basically organized, I think, by Legit Business Syndicate, which is the same folks which organized DEF CON CTF for several years. Like, even the scoreboard was quite similar. Now, I didn't play it too much. I basically just helped our team. Well, helped. I like to believe I helped a bit. But only on the second day, only for a couple of hours, I was basically trying to convince a custom build of a MAPES virtual machine to work correctly with GDB, which actually we were able to do. But that was all about all my involvement. Our team actually was a merger, a temporary merger of Dragon Sector and P4, which are like top teams basically. And this is the unofficial scoreboard because there was going to be another official one. And yeah, our teams basically scored the second place. The merger was called Poland Can Into Space, and like obvious reference to Poland Ball. And yeah, so congrats to everyone who played, and I know that the folks put a lot of effort into it. Like, some names are pretty amazing actually here. Why is Rust syntax so weird? Yeah, I would like to know that as well. Like, when I'm looking at Rust, the first thing that comes into my mind is Ruby. Like, Ruby also has a weirdish syntax, in the same way. If Spacex gets cancelled, will you stream again today? No, sorry, no. I had a tiring day, so yeah. It's another reason for me to make a shorter stream. SpaceX is a good excuse, though. Have you done any hack the box machine? Not yet. I will do them. Someday I will do them on the live stream. Foxtrot actually even got an approval for doing some old machines on the stream. Obviously not the current ones, but we are going to get there someday. Maybe after we finish Pico or whatever. Cool. There's another question. What do you think about Rust Transpiler from other languages like TypeScript and C++? What do you think about Rust? So is it compiled into Rust, or is it Rust compiled into TypeScript or C++? Well, I can answer it both ways, I guess. From Rust to anything sounds decent. From C++ to Rust sounds really problematic. It's okay, so it's from C++ TypeScript to Rust. It sounds problematic. I'm not sure if that could work due to the model differences in how object is being controlled. Sounds interesting, but I have not looked at it, but it's a good thing you mentioned it. Thank you for mentioning it. Okay, about the HTB machines, that would be great. I would love a video on a hard insane machine from HTB. Keep it up. Yeah, we will start with the easy ones though, because you know this live stream at the end of the day is 2 hours, and I have no idea about HTB machines, but for hard CTF tasks they take anything between 20 hours to 40 hours, and that's a little bit too long for a live stream. Did you ever focus on breaking out of a Solaris zone? I know of nobody who succeeded in that. Not really. I played only with Solaris. I never played with it from a security perspective. I did use it on my university ages ago, but that's about it. So no, I didn't play with it. I meant creating similar syntax like TypeScript, C++ to Rust code. But syntax isn't everything, right? Like, syntax can be easily transpiled or like compiled or whatever. The problem is actually in the model of execution in this case, because it's just not compatible. So you can transpile it like the syntax easily, but then you hit the problem with model of execution, which is different in all three of these languages, right? Because the TypeScript follows the asynchronic model of JavaScript, then C++ has this like full control execution model, well, almost full control with a lot of undefined behaviors and other stuff, and then Rust has this strict control of who owns which objects thing, and a similar threading model to C++. So yeah, this would be problematic, I would say. I like the idea, but there are a lot of problems here. Am I going to watch the launch of Dragon from SpaceX? Absolutely yes. I am trying to watch almost every launch. I even have like a photo of the Starlink train from the sky from some days ago. If you're on our Discord, you know that because we're spamming it with spamming my photo there. So I actually like space stuff. It's amazing. Okay, let's finish it here. Thank you everyone for being here. Thank you to my moderator KrzaQ again. See you next week, and yeah, enjoy the launch. Let's hope it's going to happen successfully today. And yeah, that's it. I'm going to leave you with some music. So bye bye.